The world before antibiotics was illness-stricken. A paper cut had the ability to kill you. Loved ones dreaded but were not surprised when they got news that their family member or even their neighbor had died from the latest epidemic. The sanitary revolution of the 19th century had helped greatly, but the bacteria that was causing the illnesses which were common were still able to thrive due to the lack of medical knowledge. Hospitals were available, and there were at-home remedies that people practiced, but these were not good enough to fight some of the deadliest bacteria which were known back then. Scientists worked frivolously for years before being able to find any sign of a curative for these widespread diseases, until September 28, 1928, when Alexander Fleming discovered the world's first known antibiotic, penicillin. The discovery of penicillin was a major breakthrough in the medical industry. It saved millions of lives up to today, sparked the innovation and creation of new antibiotics, and it also created a safer environment throughout the world. Alexander Fleming was born on August 6, 1881, to Hugh Fleming and Grace Sterling Morton in Darvell, Scotland. He was initially sent to school at Loudon Moor School, Darvell School, and Kilmarnock Academy in Scotland, before Fleming and his family moved to London, where he completed his childhood education at Regent Street Polytechnic. Fleming did not attend medical school right away, and instead he worked in a shipping office for 4 years due to the insufficiency of funding for the tuition of higher education. When Alexander's uncle John died, his will distributed equal shares to each of the family members, and Fleming put this money to use by using it to enroll in St. Mary's Medical School of London University. He qualified with distinction in 1906 and began his studies under Sir Almroth Wright, who was a pioneer in vaccine therapy. He achieved his MBBS with gold medal in 1908 and became a lecturer until 1914 at St. Mary's. Early on in his medical career, he was interested in natural bacterial activity in the blood and in antiseptics. Before World War I in 1915, Fleming married an Irish-born nurse named Sarah Marion McElroy, who he would have a son 9 years later named Robert Fleming. When World War I came, he served as a captain in the Royal Army Medical Corps, which surprisingly he was able to continue his studies in a makeshift lab in Bologna, France. Whilst he was serving, he also witnessed the deaths of many fellow soldiers. These deaths were not just due to the battle wounds, but also the infection that preceded them. The most they could do for the infections were pouring antiseptics in the wounds, which in reality usually did more harm than good. During this period of time, he discovered and wrote an article on the presence of anaerobic bacteria in deep wounds, which prevailed even after the wound had been treated with antiseptics due to the condition the wound is left in before being closed, and he submitted this article to the Lancet Journal. Once he was demobilized in 1918, he was able to settle and work on antibacterial substances which would not be toxic or dangerous to animal tissues. He was able to do this by going back to work at St. Mary's Hospital. In 1921, he discovered an enzyme with weak antibacterial properties which was named lysosome. Fleming was not said to have had good laboratory organization and cleanliness. This is how lysosome was discovered. Later in his career, during the September of 1928, Fleming discovers his most famous yet surprising treatment. It was completely accidental whilst he was working on common staphylococcal bacteria, a bacteria that causes boils and can create even more severe issues for patients with already weak immune systems. This discovery as well had to do with his uncleanliness and bad organizational skills. An uncovered petri dish was left sitting on a workbench, causing it to become vulnerable to contamination of mold spores, whilst he and his family were on vacation. When they had returned, Fleming had discovered that the bacteria next to the mold colonies were dying. Fleming describes the colony as a white fluffy mass which rapidly increases in size and after a few days sporulates, the center becoming dark green and later in old cultures darkens to almost black. He was able to pinpoint the mold and specify it to the mold Penicillium notatum. The mold would make the harmful bacteria it was tested on go under the process of lysis, which is when a cell is destroyed through the rupture of a cell wall. It was proven to be effective against multiple diseases such as scarlet fever, meningitis, diphtheria, and pneumonia, which were all serious issues of the time period. After further investigation, Fleming discovered that it was not the mold itself that was eradicating the pathogens, but instead it was a juice that was produced by the mold. Fleming also discovered that the antibacterial properties held within the Penicillium genus of the mold were not found in all types of molds. Fleming named this newfound organic substance penicillin. He gave his assistants Stuart Craddock and Frederick Ridley the assignment of isolating and purifying the penicillin from the mold juice. The pure form of penicillin was proven to be extremely unstable, and Fleming was only able to move along with make-do solutions. In the June of 1929, he did publish his findings to the British Journal of Experimental Pathology. Fleming and his assistants were not the only ones to tamper with penicillin. Harold Reichstrick, a professor of biochemistry at the London School of Hygiene and Tropical Medicine, also tried to purify penicillin, but he failed during his attempts as well. Later in 1939, at the Sir William Dunn School of Pathology at Oxford University, Howard Florey, Ernst Chain, and their other peers were the ones who really turned penicillin into the drug that saved and still saves millions of lives. The World War II wartime efforts of the UK were making their research extremely difficult. They needed 500 liters of mold filtrate per week in order to carry out clinical trials and animal experiments. In order to fulfill this, they needed to start growing the mold in baths, bedpans, milk churns, and food tins. A fermentation vessel was created in order for the removing of the penicillin to be easier. The summer of 1940, their experiments took huge steps in the right direction. 50 mice were infected with streptococcus, and half of those mice died horrible deaths due to sepsis, but the half that was treated with penicillin survived the infection. The team had collected enough evidence to prove that penicillin was safe to test on humans. The following September of 1940 was the first case penicillin was used on a patient. Albert Alexander was hit in the face with a German shrapnel, and the wound became infected with staphylococcus along with streptococci, and the infection spread to his eyes, lungs, and shoulder. The man was treated with Florey and Chain's purified penicillin for 5 days. The team ran out of penicillin, and Alexander died due to sepsis. Dr. Norman Heatley was a biochemist who worked on the mass production of the drug. During the 1941 summer before the U.S. entered World War II, both Heatley and Florey flew to the United States to work with scientists on the mass production of penicillin in Peoria, Illinois. Florey and Heatley discovered that the Penicillium notatum would never produce enough of the mold juice to actually treat people, so they started looking for a better species. Their search ended once Mary Hunt had discovered a golden-looking mold on top of a cantaloupe she had bought that day. The mold was discovered to have actually been Penicillium chrysogenum. This mold produced 200 times more penicillin compared to the Penicillium notatum species. Even though this species had produced 200 times more penicillin than the original species, the Penicillium chrysogenum still had to go under mutation in order to produce an end product of 1,000 times more penicillin than the mold that Fleming observed. In 1941, the UK had joined with the scientific community of the US in order to solve the problem of mass production of penicillin. It took a while before anything was able to have been done. James Curie and Jasper Kane developed technology called deep tank fermentation at the Pfizer Food Chemical Company before penicillin was discovered in order to produce citric acid. They decided to adapt the technology to better suit the penicillin production. March 1, 1944 was the opening of Pfizer's penicillin plant. The plant contained 14 7,500-gallon tanks which produced 5 times more of the drug than what was originally estimated. This burst in production made the company the leading producer of penicillin. Pfizer's company was part of the War Production Board, also known as the WPB. The WPB contained 21 companies to participate in the large-scale manufacturing of penicillin. The use of penicillin in the war decreased infection-related deaths and saved millions of soldiers. After the war, penicillin production percentages kept increasing and more lives were continuing to be saved through this miracle drug's capabilities. In 1945, Sir Alexander Fleming, Ernst Chain, and Sir Howard Florey were awarded the Nobel Prize in Physiology or Medicine for discovering penicillin and discovering its effects on various infectious diseases. The rest of Florey's team was left unacknowledged, even though they helped to make huge leaps in the development of the drug. Each scientist received 1/3 of the prize share, and each gave their own speech. Penicillin is now 91 years old. Since then, diseases and infections which were once fatal are now easily treatable, and more antibiotics such as amoxicillin, ampicillin, and countless others have been developed in the past 90 years. Since the early 20th century, bacteria is becoming resistant to penicillin along with other antibiotics that were a result of the innovation, which was a result of the discovery of the miracle drug. Alexander Fleming even predicted this when giving his Nobel speech when he said, "The time may come when penicillin can be bought by anyone in the shops. Then there is the danger that the ignorant man may easily underdose himself, and by exposing his microbes to non-lethal quantities of the drug, making them resistant." But even though this slow but sure resistance is happening, it doesn't deny that penicillin saved millions of lives all over the world.